Good morning, students. This is our lesson from Monday, January 11th. We're talking about how to write words into equations and solve them. And we're really going to focus on how do you find those variables and how do you walk through them. So join me in the Desmos activity that your teacher shared with you, and you can kind of walk through some of these. Take down this information in your notes because then we can use it later as we go through. So this do first says, use the side lengths given, find the area and perimeter of this rectangle. Well, do you remember, we find perimeter by just adding up each of the side lengths of our object. So here we have a rectangle, we're going to add up all four of these side lengths. And so, we could call this the height and the base and a height and a base, or sometimes you see 2L plus 2W, which just means both lengths and both widths. In order to find the area, remember we multiply the base and the height. So we're going to multiply our base times our height. So take a moment, try that out, and then come back and see how you did. So this is the answer from slide 2. And what I want you to look at is this first part, the perimeter. Notice we just added 2x minus 3 plus 2x minus 3 plus 3x plus 1 plus 3x plus 1. Then we combine like terms. All our unknowns, the x's, and all of our constants, -3, -3, 1, and 1. And we came with 10x equals, or 10x minus 4. So our perimeter is equal to 10x minus 4. And remember, our unit was in inches. Just so you remember, inches is how we're going to be finishing this. And then our area, we said area is base times height, and so we multiplied the 2x minus 3 times the 3x plus 1. I used the area model for this, a binomial times a binomial. Came up with 6x squared minus 9x plus 2x minus 3, and combined like terms in the middle here, negative 9x and positive 2x, and came back with this final area of this rectangle is 6x squared minus 7x minus 3. And again, that would be in inches squared because we multiplied a length times a length. Now, you're like, well, how does that help me out? I don't know anything else about this. Well, go back to the first page and you see we also say the perimeter is equal to 36 inches. If I know the perimeter is equal to 36 inches, and I know the perimeter is equal to this expression, 10x minus 4, do you know that we can say the perimeter of the rectangle equals the perimeter of the rectangle? That's kind of a duh statement, but think about it. If I know this is the perimeter and this is the perimeter, we can set them equal to each other. And so we say 36 inches is equal to our expression 10x minus 4. And now we solve. We add 4 to both sides. And we get 40 equals 10x. Maybe you see we can divide by 10. We know that x is equal to 4 inches. Now, since we know x is equal to 4 inches, we can actually find out what each of our lengths are. And so we just substitute it in 4. 2 times 4 minus 3, we get 8 minus 3. And I know this side length is 5 inches. We call this the height, but it's the width or whatever you want to call it. It's 5 inches right here. I'm going to just switch colors so we don't get these confused. 3x plus 1, 3 times 5, or 4, sorry. 3 times x is 4, plus 1, we get 3 times 4 is 12, plus 1 is 13. So both of these are 13 inches. All right, that's awesome. Now we know we have a rectangle that's 5 inches by 13 inches. We can use that to find our perimeter, right? Guarantee it is 36. 13 plus 13 is 26, plus 5 is 36. But then we can use it to find our area. We can either plug 4 into this problem down here, or just use our base and height, 13 times 5, and remember that's inches times inches, and so we get 65 inches squared as our area. That's a fun problem when you break it down and you look at each of those parts. So, nice work. So here was our goal for today. We're going to define variables. That means we're going to say this variable means something. And we're going to do it by using something called a let statement. I want to walk through those let statements. And it's going to be something I want in the back of your head so that you can see that as we move forward. All right. And so we have a slide sort here. And so we have 4 different ways of looking at this stuff. Or 4 different problems to think through. Oh, mine's trying to play nice with me. All right. So read through these and then come on back here. All right. If you can match these up, go for it. This is not how they match up. I'm just sorting them. So read through them, see if you can match them up, and then come on back. All right. When you're done with that, you can go to slide 12 and check your work. If you understand it through this, you're on the right track. I'm not trying to say this is something brand new, but if you're struggling, watch the rest of this, okay? Okay, hopefully you tried those slides 11 and 12 a few times, and if you got them right, if not, watch this and then go back and try that again. And so here's our let statement, and there's a lot of words here. I want you to focus on one side if you want to read it in English or if you want to read it in Spanish. All right, in Spanish, notice a let statement we're calling a suposición. It's not a correct translation, but the idea is the same from what I understand. It's this is something, or we're going to make this equal to something. So this example, if we're solving a problem about grilled cheese sandwiches, we might begin by writing let S be the number of sandwiches eaten. So we're in power here. We get to control what we're going to decide these things are equal to. This is example 1 here that we matched with A. And so if you go back and see, we said 2Z plus 12 equals 30. Zola earned $30 by working 2 hours and receiving a $12 bonus. So our variable, we said let Z equal Zola's rate of pay. She could have been, right? To get $30, we know she worked 2 hours. We don't know how much she was paid. That's the unknown. And so we say, let Z be that unknown, Zola's rate of pay in dollars per hour. All right? And then we can solve for that. We're not going to do it yet. But that's what we call a let statement or a supposition, right? It indicates what we're trying to find. And one last note here. A let statement always indicates the unit of measure if there is one. And so dollars per hour, right? Z is how many dollars she makes per hour. So there's 3 more of these, right? Here, Eddie, who earns $5 more per hour, worked 2 hours longer than Zach, who earns $12 per hour. Go ahead and try out what you think that Z should stand for, okay? We find this is the correct one, but when you try that, type it in here, and then see your answer on the next slide. It says the let statement, Z is the amount of time Zach worked in hours. All right. And so we know that if we look at this equation, Zach worked a certain number of hours times $12. Eddie worked 2 hours longer. So you can see we have a single variable, Zach's hours of work, and then we know Eddie works 2 more hours than that. Go ahead and try slide 16. Pause it and check it out. All right, maybe you're starting to see, come back here and you can see that Z is the number of zebras. And then we could do the rest of these based on the zebras. Z minus 2, that's the elephants, and then 5 times Z minus 2, that's the monkeys. Finally, we had the problem that talks about zinc and silver. Well, we know that we could have 12 times the number of silver than we do zinc. And so we can say let Z equal the number of zinc, and then we have 12 times Z gives us our silver. All right, now, so if that makes complete sense to you, how to make those let statements stand for something unknown, excellent. If it doesn't make sense to you, we're going to keep looking at some new ways of walking through variables. So we really have 4 more problems in this lesson, and I'm going to walk through them a couple of ways, and maybe we'll have to come back to these a few times. The next problem starts in slide 20 and has 3 parts. So I want you just to investigate this one on your own. The answers are there. So walk through that from slide 20 all the way up to slide 23. All right, we're going to move ahead to slide 24 and 25. And I want to just walk through a way of possibly solving these. I call it guess, check, generalize. And we're going to walk through what that looks like. Again, it's a skill that you have to develop over time, but watch this and see if you can figure that out. All right, and so we really want to set up a strategy here. Slide 25, question 4.6a. After the math contest, Basil noticed that there were 4 extra large pizzas that were left untouched. In addition, another 3 slices of pizza were uneaten. If there were a total of 51 slices of pizza left, how many slices does an extra large pizza have? Let's approach this problem in a way that I said, guess, check, generalize. And I'm guessing you were like, my teacher always told me, don't just guess. Well, this is a different way of guessing and checking. So let's take a moment and think through. So go to the end here. What is it really asking? It's saying, how many slices does an extra large pizza have? How many slices does an extra large pizza have? Well, you've all had extra large pizza, I think. Just take a guess. And if you guessed, I think an extra large pizza has 8 slices. What does that mean? That means that we have 4 extra large pizzas left with 8 slices. So I'm going to do 4 extra large pizzas times 8 slices. And then it says, in addition, another 3 slices of pizza were uneaten. So we know we're going to have 3 more pizzas. So 4 times 8 plus 3, we want that to equal 51. Did you follow? So we guessed 8 slices. That's not anywhere else in here, but we guessed this number. So what is 4 times 8? It's 32. 32 plus 3, that's 35. So that is not 51. So I do this. I say, nope, that didn't work. So let's guess another one. Guess number 2. And I'm going to do this in another color so we see our different guesses. I'm going to say, well, maybe it's 10 slices. So I'm going to say 10 slices. Well, if I have 4 pizzas, 4 times 10 gives me 40 plus 3. So 40 plus 3, is that 51? Nope. But I'm getting closer. And so guess and guess and guess until you either get the right answer, or what I really want us to do is guess, check, and then we're going to try to generalize what's happening. So let's make one more guess, and then let's see if we can see what's happening. So I'm going to guess 11 slices because I'm getting closer. Or, maybe I'll do 20 slices. Make sure that because I kind of only went up from 35 to 43. So let's guess 12 slices or 20 slices. And so I have 4 times 20 plus 3. Well, 4 times 20 is 80 slices plus 3 gives me 83. Is that 51? No. What if I don't know how many slices it has, right? That's our whole problem. So my generalization could be X, right? Let's guess X number of slices. Well, we're going to do the same thing. 4 times X plus 3 equals 51. And we have this problem then, 4X plus 3 equals 51. And you know what we just did? Is we just created an equation to find the number of slices. So go ahead and solve that and see if you can find it. Hopefully you pause this, try it out. I'm going to give myself a little more, well, I think I can do it here. What we would do is we just subtract 3 from both sides, and I get 4x equals 48. What's 48 divided by 4? X equals 12. So my answer, x equals 12, but 12 doesn't make sense. It's 12 what? How many slices? 12 slices. So that's the introduction to Guess, Check, Generalize. I'm going to make another video for the next two pieces because we're running out of time.